Dear students of 9th standard, let us discuss the questions and answers given in the model paper 2026, the latest model paper which is released from the SSLC board. Now let me discuss the questions and answers of physics now. The first question is, a hearing aid is a device that helps to perform using which type of energy or the source of energy? That is the first question. The proper answer to be selected is dry cell. Because the hearing aid is used inside the ear, it needs some energy source. So it uses very small dry cells. Now second question, what is the SI unit of pressure? The answer is Pascal. But listen to the other choices also. Newton is the SI unit of the force. Joule is the SI unit for energy and also the work done. The watt is the SI unit of the electrical power. Third question, let us take. It's a problem based question. A man claps his hand near the hill and he is able to hear that sound, the echo of that sound after 5 seconds. What is the speed of the sound? If the sound travels 346 meter per second speed, then what is the distance traveled by the sound? That you have to calculate. It is based on speed is equal to distance by time formula. You have to change the formula in such a way that you should be able to find the answer. So distance traveled by the sound is equal to speed into time. So 346 meter per second into 5 seconds will give you 1730 meter. Now this question can also be asked in another way. Find the distance between the man and the mountain also can be asked. If you are able to hear the echo, the sound is traveling 2 ways between the man and the hill. So you have to divide it by 2. You have found already the total distance traveled by the sound as 1730 meter. So to find the distance between the man and the mountain, you have to divide it by 2. So you will get 865 meter as the answer. Now let us move to the fourth question. Explain the different types of energy change that happens when you pedal the bicycle. Now while pedaling the bicycle, the rider's muscular energy is converted to thermal energy. The body heat rises. So thermal energy is formed. And also the cycle moves. The wheels move, rotate. That is nothing but the kinetic energy. So muscular energy changes to thermal energy and kinetic energy. And also if there is headlight for the bicycle, the muscular energy is changed into the electromagnetic energy, and then that is converted to the electrical energy, and then finally the light energy also. Now the fifth question is based on speed and time graph. The speed is given as 5 second, 10 second, 15 second. A regular interval is there in between them. The gap is very common in between all the values. The second column is for time. Time is 10 second, 20 second, like that. There is also a regular gap in between the time lag. Now the questions will be asked based on this table. Let us see the first question. What form of acceleration does the vehicle's motion have? This is called uniform motion or uniform acceleration. Because if you divide 5 by 10, you will get 0.5. And if you divide 10 by 20, you will get 0.5 again. So for every value, you are having the same ratio. So it is called uniform accelerated motion. Now B part asks the questions like this. what shape will be the time velocity time graph of the vehicle take? This is nothing but the straight line. Straight line in this way. Let us see some of the diagrams. First diagram, what is given here, the parallel line to the x-axis. X-axis is taken as the time and y-axis as velocity. Now AB is the value for the ratio of velocity by time. Now for the given values, it is the uniform velocity and zero acceleration. So AB is the line. You will get this kind of straight line which is parallel to x-axis. Now second point, if the same question is little bit asked in different way, what is the shape of the graph when you draw the values for uniform acceleration having the increased acceleration? So from 0, that is at rest, the vehicle is started. If it reaches the highest acceleration in a given time, then the graph will be like this. Okay, if the vehicle is not at 0, it is already running, but it is at the beginning slow, but when the time passes, it becomes more accelerated, more faster, then the graph will be like this. So all the three are uniform accelerations, uniform motions. Now in this diagram, in both these diagrams, the vehicle or any moving object is showing non-uniform acceleration, but at the beginning the acceleration is slow in the first one, and in the second one the acceleration is very fast, then it goes on becoming slower. But in the first diagram, the acceleration becomes more when the time passes. Let us see this diagram also. This is also a uniform acceleration, but this is the retardation, that is the moving object becomes slower and stops. That is the meaning of this diagrams. So if the same graph is asked in different cases, you should be able to find whether it is uniform or non-uniform motion. So if it is uniform, it will be straight line. If it is non-uniform, it will be curved. If it is faster, then it has to rise upward. If it is slower and comes down to rest, it has to touch the x-axis at the end. Now let us take the a choice question. There is a choice for the same question. An artificial satellite moving in an orbital path of radius r kilometer takes 1 day to complete 1 revolution around the earth. Now let us understand this question by the help of a diagram what I have created. Now you can just refer to the earth in the middle. I have drawn this. When the satellite goes round the earth, it will be a circular path. So the circumference of the circle itself is the distance travelled by the satellite. Now circumference is calculated by the formula 2 pi r. Pi has the value 22 by 7. So 2 into 22 by 7 into r. R is not given as a value. It's given as a unknown value only. So keep the r value like that only. Now let us go to the question part. Calculate the satellite's orbital velocity. What is the velocity of the satellite while it is going around the earth in a circular path? That is the question. So velocity is equal to the distance travelled divided by time. So distance travelled is nothing but the circumference 2 pi r and divided by the time. 2 pi r is nothing but 2 into 22 by 7 into r divided by 24. Now if you take the value 22 into 2 is 44 divided by 7 into r into 1 by 24. 24 is in the denominator. So take it as 1 by 24 and cancel wherever it goes. 24 goes by 4, 4 6 are, and 44 also goes by 4, 4 11s are. So 11 by 42 is the answer. 7 6 is 42. 11 by 42 is nothing but, if you divide it for decimal number, you will get 0.262 kilometer per hour. That is the final answer. Velocity is equal to 0.262 into r kilometer per hour. If in a problem r value is given, multiply the value here, or even you can multiply in the earlier steps itself, where you can cancel it and get the easier values. Now, B part is very easy question. SI unit of speed is asked here. It may be asked also for velocity or acceleration also. For speed, meter per second is the SI unit. For velocity also same, meter per second. If it is asked for acceleration, it will be meter per second square. Now C part. In the C part, the question will be like this. When a player applies a force on a shot put ball of mass 6 kg for 2 seconds, its speed increases from 3 meter per second to 7 meter per second. What is the value of the force applied? Now given values, we have to write. U is equal to 3 meter per second, V is equal to 7 meter per second, U is the initial velocity, V is the final velocity, T is time 2 seconds, mass is 6 kg. Now when we calculate, the formula applied here is F is equal to M into V by V minus U divided by T. So if you apply the values 6 into 7 minus 3 divided by 2, you will get 3 by 4 and 12 Newton answer you will get. The next question what we are going to is explain why the acceleration due to gravity on earth is different at equator and at the poles because of the change or difference in the shape of the earth. Earth is little bit flatter in the poles and little bit bulged in the equator region. When it is flatter in the pole, from the center of the earth, the distance to the pole is lesser when we compare the distance between the center of the earth to the equator. So distance decreases and the gravitational force also increases. So at the pole, acceleration due to gravity is greater than the equator region. Now, 8th question, let us take some important measures are asked to reduce the resonance when the sound is produced. When in case of big halls or lobby, we have seen this resonance of our own sound and we are not able to hear the sound properly. It interferes with the quality of the sound also. So what they will do is, in big halls, cinema halls or big lobbies, you will see that the wall and the ceiling will be plastered with the thick plastering materials. Maybe it is made up of some sound absorbing rough fibers, or maybe some wooden boards, or maybe some fiber like structures. There will be grooves in the ceilings. Some of them will tie the earthen pots to the ceilings so that the smoothness of the wall will be countered and there will be some constrictions, gaps in between, so that the sound will not get resonanced. Now let us take another question, 9th question. In that there are some parts A, B. A part asks the questions like this. Define the law of universal gravitation. This is very, very important. The force of attraction between any two objects is directly proportional to the product of their masses, and inversely proportional to the square of their distance. Here is the formula: F is equal to m into m on the numerator divided by d square in the denominator. D square is the distance, square of the distance. M is the mass of the big object and small m is the mass